agents are everywhere. Not only are they within all of the different tools and products that we're using these days, but everyone seems to be talking about them. Now, it's great that lots of these tools give you the ability to even create your own AI agents, but what if you actually wanted to create your own custom-built AI agent yourself? This would not only mean really hefty prices that you have to pay, but it gives you a lot more control and freedom over the AI agent that you want to build, and could even give you the possibility to sell and commercialize this AI agent as well. So today we're going to be diving into a library called LangGraph, which is built upon LangChain, and this has so many really useful features that you can use to build an agentic framework. And actually all of the big tools out there that have created AI agent tools and platforms are almost all completely built upon LangGraph. So let's dive into it. So this example is going to walk you through how to build an AI customer support agent. Now, customer support and customer service and even sales has been one of the first industries and domains that has really been hit hard with AI agents. One of the reasons why is because a lot of the work that they do on a daily basis can be automated and can be handled by an AI system. It doesn't mean that they're not necessarily useful in any other way, but what it means is that they can focus more on the high value tasks, such as actually dealing with customers face to face and building those relationships. And then things like answering really basic queries, following up with information, enriching CRM and database information, that can all be handled by AI agents, and it is today. So let's start walking through the code. So just to talk a little bit about the actual overall structure of the repository that you'll be using here, the main entry point that you'll actually access the application through is the main.py file. And then the actual brains behind the whole AI agent is stored within the AI folder within the graph.py file. Within here, you'll find some classes and some functions that the classes utilize as well. The only other significant thing to note here is the data folder. So this data folder will contain a customer inquiry information structure. So we're going to access data from the data folder, which is just a JSON file, essentially to simulate how an AI agent could go out and collect information from a database or from a CRM system, for example. Now, one really interesting strategy that I'm actually using with clients at the moment is, rather than fetching data from a local JSON file, which is not always available in production systems, but is fetching data using tools from a CRM system. But going and fetching data from a CRM system every single time can be very expensive. So what we're actually doing is we're implementing a really clever caching strategy, which will load all of the relevant information about the customer into a cache before the call starts, based on some kind of trigger or event. And then that AI agent just needs to go to the cache, which is a much faster retrieval of information than actually having to go all the way to the database or the CRM. Now, that's just to give you a bit of insight, but we're not going to be doing that for this example. We're just going to be using the local files that I mentioned. So as always, we're working in Python, and whenever you start a Python project, you obviously need to create a virtual environment just to keep everything nice and isolated and to keep everything away from the system. So we'll create this virtual environment really quickly, and then we'll activate this virtual environment. And then if you're familiar with Python, then you'll also know the next thing after that will be to install the requirements. So the requirements for this repository are actually very simple. It's just a few libraries, mainly libraries and different abstractions of LangGraph and LangChain. And we'll also be using the Anthropic API as the underlying large language model. So we'll also import the Anthropic package too. So this first block of code that we're going to copy is for the graph.py file. So we'll start populating this. So as I said, this graph.py file is really what we're going to be using as the brains behind the whole AI agent. So the first thing that we'll do is import all the different libraries and packages that we need. And then we'll start defining some constants. Now, these constants are, first of all, the model that we're going to use. We're going to use a very basic model for this example. You can bump this up to one of the more recent Claude models if you wanted to, like Sonnet 3.5 or Sonnet 3.7. But actually, for this example, speed is really important and latency is really important. And as you'll see in the demo, there's definitely some improvements just by running it locally that we can make here. But given that all of the information that we're going to be providing about the customer is already known to the AI agent, i.e. in the form of the JSON file that we'll load, and given the prompts that we'll engineer to make sure that it has all the context that it needs, the actual reasoning power that the AI agent needs isn't actually that high. Therefore, you may not need a really complicated model with a lot of reasoning power. So something like Haiku actually works really well. So if I now move down to the role, this is where I'm going to define and tell the AI agent, this will be passed in one of the system prompts, what the AI agent's role is. So I'm basically telling it that you're going to be a customer support agent for a domestic robotics company called HomeBots. The purpose of the call and the reason why the AI agent is calling a customer or speaking with a customer is that you're following up with a prospective customer that has inquired for more information online. So if you can imagine, you might be shopping online for a robot that you need around the house, and you might have filled out an inquiry form, which for high ticket items or for very bespoke items is quite a typical sales cycle. So I've inquired online, I might have given some basic information such as my email and my name. So that's been logged in the domestic robotics company's backend. And then now, traditionally, someone would have to physically call that person up or email them to then figure out, okay, well, what product do you want? And what's your budget? And when do you want it delivered by? All this sort of very basic, simple stuff. But what the AI agent will do is it will actually have that conversation with the customer. So then, giving a little bit more context, we let the AI agent know, well, what is it that it needs to do? So we let the AI agent know that it needs to collect all these different pieces of information from the customer. That includes the customer name, the product, the delivery address, email address, phone number, payment method, and desired delivery date. You can obviously customize this to whatever you want for your specific use case. And we also give it some context about the different products that the company offers. So it offers the HomeBot 1000, 2000, and 3000. We then define the actual task that the AI agent needs to complete. So I find this to be a really good best practice when building AI agents that need to go through a series of steps or need to tick off a series of checkpoint items before they can actually end the conversation. So by making it really clear about all the different things that the agent needs to do, such as greeting the customer, confirming their name, and then secondly, checking the customer inquiry data, so then going and fetching the data from the JSON file or from the database. After that, if any of the checklist items are missing, one by one, go through those items and ask the customer for the answer to those items. And then when everything is done, then we can essentially end the conversation. So by defining it really clearly like this, it gives the AI agent a structure to work within. And it also allows them, because AI agents are a much more dynamic way of working with LLMs, it gives them a framework to then work within. So then if the customer, for whatever reason, goes off track or asks a different question out of scope, the AI agent is able to return back to what it should be doing. And then finally, I've defined some rules at the bottom as well. This is really useful to just make sure that the AI agent, once again, stays on track and knows the bounds upon which it's allowed to work within. So here, this is where you can define things like tone of voice. You can define that, things need to be kept very clear and concise. You can also make sure to enforce rules such as, only focus on one question at a time. Don't overwhelm the customer with multiple questions. And you can reiterate any important points here as well that you want to make sure the AI agent follows. So there's no real actually kind of like building of the AI agent here. This is really just setup steps in terms of the prompts that will be fed to the AI agent. So the next thing that we'll define is the state. Now this state definition is a strict typed class. Now by defining the state like this, it enables the AI agent to make sure that all of the information that it collects follows this strict typing. So basically what it's saying is that all the information that we need, customer name, product, delivery address, email address, phone number, payment method, and delivery date must all be strings. We've also got a messages field here as well, which will store an entire history of all the messages that go backwards and forwards between the AI agent and the customer. And then we have a couple of flags at the end as well. So it has the conversation finished and has the AI agent gone and checked the checklist for the customer. So this definition will be used by the AI agent to essentially keep track of the entire conversation. After that, we're going to start defining some tools. Now, within an agentic framework, a tool is essentially a modular piece of functionality that you can enable or equip the AI agent with. And it's actually one of the massive benefits of AI agents. So you can give an AI agent an entire array of tools within its arsenal, and then the AI agent itself, through the intelligence of the LLM, will then decide which tool to use at which specific moment. So as an example, the first tool that we've created is the check required checklist items. And what's really important here is that you have to make sure that these functions are not only named appropriately, but also have an appropriate and descriptive docstring as well. Because the LLM itself will use the docstring and the name of the function to decide whether or not to use a particular tool or not. So the logic within this tool, essentially, first of all, it short circuits. So it short circuits if the checklist items have already been checked. So we're not going to bother loading the JSON file again if the JSON file has already been loaded. So that's fine, this first code block here. And then if the JSON file hasn't been loaded, we're actually going to load the JSON file, which is within the data folder. We're going to update the state with the information that's within the customer inquiry JSON file. So whatever information that we've already collected about the customer, let's store that in the state of the conversation. And then what we're going to do is we're going to check all the required fields and make sure that there is nothing that needs to be checked with the customer. If there is stuff that needs to be checked, then we're actually going to change the state of the conversation to is finished, because we no longer need to collect anything from the customer. And then finally, we're going to send a command to the AI agent just to update the state with the latest message and all of the updated values. The second tool is the explain product tool. So as part of the conversation, if the customer wants an explanation about a product, then this tool will essentially explain that product to them using the context that has been provided in the system prompts. So once again, this could call out to a database to gather information about a product, but we're keeping it simple for now, and we've hard-coded these explanations. So this tool essentially will look up the name of a product, and it will return an explanation of that product back to the customer. So it's pretty simple. And then the last tool is actually a passing date tool. So this is going to be useful for when we want to establish the delivery date for the item. So this tool will take in a date from the customer in whatever format the customer gives it in. So it might be in spoken language form, such as 29th of March at 5 o'clock. It might be, I don't know, next Tuesday at 4, or it could be really vague or very specific. And the LLM itself will use its intelligence to essentially process this date and output it in a standardized format. And once it's done that, once again, it will just update this information within the state of the conversation. So those are the tools. The next thing that we need to do is we need to actually define the AI agent itself and the graph that we'll build using the nodes and edges that we need within the graph. So this is really where we'll start utilizing the power of LangGraph. So as you can see from the AI agent, we initialize the class just by defining some of the properties that we'll use for the system prompt. And then the main method that we'll use here is the build method. So within this build method, we instantiate the state graph that we'll use. So this is the state of the conversation. We also instantiate the underlying LLM that we want to use, which in this case is the Anthropic model. After that, what we'll do is we'll bind the tools to the LLM. So we'll essentially equip the LLM with all the tools that we want it to have available. And then we'll start adding nodes to this graph. Now, the actual graph in this example is very simple. I've worked on lots of other graphs that are much more complicated, where you have lots of nodes and you have supervisor and worker nodes, you have a QA node, you have an approval step, all of that sort of stuff. But because this is a conversational AI, really all we need is a chatbot. And the chatbot is the central node, which will then have all the logic, have all the tools at its disposal, and it will dynamically decide what it should do next in the conversation. So there's 3 nodes, in fact. We have a chatbot node, we have an end node, which will end the conversation and end the running of the graph, and we have a tools node as well. So we'll add those 3 nodes, and then we just need to add some edges that actually go between these nodes. So we define the entry point, which is, of course, the chatbot. We then define some conditional edges, which essentially will have some conditions upon which the chatbot is able to use the tools. And then we'll compile the graph. And then the next 2 helper methods below essentially just define the actual content of the nodes. So we have the chatbot node method. In this logic, we have a block of code, first of all, which will just make sure that if we know the customer name, do not ask for it again, because obviously this spoils the user experience somewhat. And then there's not too much else within this node, really. All we're actually doing is we're compiling all the different messages within the state of the conversation, and we're passing it to the chatbot, because the chatbot will really do all of the processing and figure out all of the next steps in terms of what needs to be done. So once we compile all of the messages, we're going to then pass that to the chatbot, and it will decide what to do next. And then the end node, once again, is very simple. Essentially, we're just setting the isFinished flag to true, and we're returning an empty messages state because the conversation is now over. So then the last thing that we need to do in this graph.py file is just initialize the initial state of the conversation. So we're just going to instantiate all the different keys and values that we need. So this is where we can define the system prompt. This is where we can define the first message from the assistant as well. So this is what will be read out on the terminal to the customer when they first start talking. And then we'll just instantiate all of the different variables that we need to start off with, including the flags and the text-based variables that we need to populate throughout the conversation as well. So that's everything that we need for the graph.py file, really. The only remaining thing to do now is just to create the entry point, which is our main.py file. So I'm going to copy all of this code, and then we can dive into it and go through it in a little bit more detail. So to start off with, we are importing the different classes and functions and state that we need from the graph.py file, and we're instantiating those things. So we're building the AI agent, and then we're actually building the graph as well. Now this next function, the stream graph updates, when you work with LLMs, you can work synchronously. So essentially you send a message to the LLM, you wait for the LLM to come back the response, and then you present the response or do something with the response. But in a conversational environment, especially when you start thinking about voice agents and conversational AI agents, sometimes you don't want to wait for the LLM to come back with all of the answers. Now, because our LLM will be making several different calls within the graph itself, the LLM is kind of able to think and have intermediate thoughts before it gets to its end thought. So for example, when it calls a tool, there'll be a response when it comes back with the response from the tool. And therefore, all of that information is quite useful to actually display to the user. So for example, if the AI agent is going to fetch the information from the database or from the JSON file, that's quite useful for the user to know, especially when you think about user experience. So rather than synchronously working with the LLM, we're actually going to stream updates from the graph and present those on the terminal as they're happening. It helps in terms of user experience, and it actually makes the overall conversation flow much better. So this block of code really is just a loop just to process all the events in the stream from the graph. It's compiling all of the messages from the stream, and then based on whether it's a message from the tool or from the AI agent, we will then present it in a slightly different way. And then really, because this is a continuous conversation, all we need to do then is essentially run the conversation within a while loop, just to make sure that it is constantly running until the exit conditions are met. So first of all, the application will ask the user for some input, and then it will start the conversation. And then the exit conditions, so this is if all of the information that we need from the customer has been collected, or if the is finished flag has been set to true. And then what you'll see here as well is that at the end of the conversation, we'll output an entire log of that conversation to a JSON file. So it's very typical in these sorts of environments, in these customer support environments, that logs of conversations with AI agents need to be tracked somewhere. So by outputting it into a JSON file, we can keep that on our local machine if we wanted to, but in a production environment, you'd probably save that in a database somewhere. So that's everything for the main.py file. The only thing to do now is actually to test out this agent. So I'm going to open up the terminal, because everything in this AI agent, for now at least, is done within the terminal. And before I actually do anything, I'm just going to clean up the terminal so that there's a bit more space. And before I run the main.py file, I'm actually just going to show you what the data file in the data folder looks like. So it's a very, very basic JSON file. So as I said before, this is really to simulate how the back end of a business may collect information about a customer inquiry. So for this example, we're providing the AI agent only with the customer name. We could have provided it with something like an email address or a phone number, which realistically, in a customer inquiry scenario, they probably would have provided that information. But once again, keeping it very simple for this example, we're just providing the AI agent with the customer name. But you can, of course, populate this JSON file with as many different fields as you want. So now that that's clear, let's start running the AI agent itself from the terminal. So first things first, you'll notice that the first message comes from the AI agent. It's saying, "Hello, I'm Hamish from HomeBots. I'm reaching out with regards to your recent product inquiry. To begin, please confirm your name." Once again, it's very common for AI agents who are reaching out to customers to have some sort of authentication or confirmation step at the beginning of the conversation. This could be a reference number, it could be an ID, or it could be a name or a date of birth, for example. Once again, this is just to illustrate how this could work. So I'm going to just confirm my name. Yep, my name is Aaron, of course. Now notice, you'll be able to see that there's been some output from the tool here. So this is once again really nice, not only from a debugging point of view, but also from a user experience point of view. You would of course format this slightly differently in a production environment. But notifying the user that, okay, I've actually gone and used a tool. And this tool has been the checking the checklist items tool. So I've gone to the JSON file and I can see, based on the tool that I've been using, that there's a few fields that are missing, and it's actually listing all the fields that we need to collect. So then once the AI agent has used that tool, that information gets passed back to the AI agent itself. This is why the agent has come back with the response that it has. So it said, "I see we have a few details to confirm." That is very true. Let's start with our HomeBot product line. We have 3 models available, the 1000, 2000, 3000. Would you like me to explain the difference between these models? So that's great. That's a really helpful response, to be honest. And yeah, I would like you to explain the differences. So I'm going to go ahead and let the AI agent know that. Now, once again, what you'll see here is that the agent is thinking in quote marks. It's gone to the tools, it's collecting all the information about the 3 different products, it's then compiling that information, and the AI agent is now able to present that all back to the user. So it's given me a summary of all 3 products, which is perfect. And then it's asking me, what model is of interest the most? Would you like to choose one of these for your home? And yeah, absolutely, I'd love to. So I'm going to let the agent know that once again. And in this example, I'm going to go for the 3000, I think. So it's come back once again. It's being very pleasant, being very amicable with me. Excellent choice. Thank you very much. It's just sort of summarizing, why the HomeBot 3000 is a great choice. Once again, it's got a built-in sauna, which is pretty cool. And now it's like telling me, okay, let's continue the conversation essentially. There's a few more things that we need. Can you provide me with the delivery address for the HomeBot? So once again, quite an important piece of information that the company would need. So yeah, I'm going to provide my address. Now, obviously with all these tools, you will, especially with things like address, phone numbers, that sort of stuff, you'll want to have deeper levels of validation of these as well. So you can call external APIs to validate these. You can have some rules in your code to validate phone numbers, that sort of stuff. But once again, for now, I've kept it very simple, but you can add this in very easily. So I've given my address. It said that it's recorded my delivery address. That's great. Now I need your email address, obviously for confirmation. So that's absolutely fine. Once again, I'll just put my email address in. Thank you very much. Yep, that's great. The AI agent has noted my email. Now, can you provide me with your phone number? So yeah, once again, this is absolutely fine. As I said before, you can add varying depths of validation here. For this example, I haven't really added any validation, but in a production environment, you definitely want to do this. So continue with the conversation. Once again, this AI agent's doing a really good job in terms of focusing on the tasks that it needs to get done and being very concise with it too. So now I need to know your preferred payment method. Do you want to pay by credit card, debit card, bank transfer, or another payment method in mind? Now, one of the beauties of working with LLMs is that it's not rules-based. It's very dynamic and it's fluid. And once again, you can build rules in here as well. So as a company, you may have a preferred payment method and you might want to encourage someone to use that payment method. In this example, once again, I haven't put too many guardrails in place, but I'm actually going to try and throw it off a little bit. And I'm going to say, actually, I'd prefer to pay in cash on delivery. Of course, this may not be an option that a customer or a company would want to satisfy. So there could be some rules to actually deny this as an option. But for now, this company, HomeBots, is happy with that. So that's absolutely fine. So the last thing that the AI agent needs to know is when would you like this to be delivered? So I'm going to say 30th of April at 3 p.m. Now this raises an interesting point. So see what comes out on the terminal here. You can see that the tool has been called and it's processed the date as in the correct format. But notice that it's processed the date as 2024. So 4th of April in 2024 at 3 p.m. Now this is interesting because I'm using one of the older models of Haiku, and LLMs in general don't have a concept of what the current date or time is. Therefore, what you can do to alleviate this is as the AI agent gets instantiated, you can give it that knowledge of what the current date and time is. So if I'd have passed that into the context of the system prompt, then it would have come back with the actual date that I needed, which is the 30th of April 2025 at 3 p.m. But because the LLM doesn't have a concept of what date it is right now, it thinks we're still in 2024. So you can see the past date tool has been called, which is great. It's passed the date in the correct format, which is exactly what we need. And then another tool has been called, which has basically told us that we've got all of the details that we need. Now we can proceed with ending the conversation. So it rounds out with a kind of thank you message. It confirms everything, and then it says thank you for your time, goodbye. So as I said before, the exit conditions have been met, and therefore the conversation has been exited, which is what we want. We don't need the AI agent to do anything else. We want to keep conversations fairly short and sweet with customers, so there's no need to drag things out. So this last thing I'll show is the log that's come from the AI agent. So as you can see, all the data fields that we defined have been filled in, and that's why I exited the conversation, because it was able to collect everything. So it has checked the checklist. It's gotten my name, it's got my address, it's got my delivery date, it's got my email address. The is finished flag is obviously set to true, because otherwise it wouldn't have exited the conversation. And especially in a production environment, it's got a complete log of all the different messages and all of the content that's come back from those messages as well. So we can go through that. We can keep a log of that in the system. This is really good from a traceability and an audit perspective, especially in production environments. And then at the end, we have a few of the extra fields as well. So we have the payment method that I wanted to pay with, the phone number, and the product that I actually have chosen to. So that is our AI agent. It's actually very simple in terms of setting it up and running it. And by using the system prompts that I've defined in the format that I've defined, use this as a template to then build more complicated scenarios on top. One of the beauties of building an agentic framework like this is that you can have one agent hand over, or talk to another agent as well. So this customer support agent could reach out to the complaints agent if the customer is getting upset or getting angry, for example. And I've shown you how to put guardrails or checks in place as well, using things like tools and by giving the AI agent guidance through the system prompts as well. So by all means, use all the different AI agent tools that are out there. But now with this video and with this walkthrough, you should have a good idea of how to actually build these things from scratch as well. And if you were to then connect this with a text-to-speech and a speech-to-text model, as well as some kind of transcription service, you could build yourself a really, really powerful tool. So I hope you've enjoyed this video. If you have anything else that you'd like me to create, let me know in the comments below. But otherwise, I'll see you soon.